In mathematics, tensors are geometric objects that describe linear relations between geometric vectors, scalars, and other tensors. Elementary examples of such relations include the dot product, the cross product, and linear maps. Geometric vectors, often used in physics and engineering applications, and scalars themselves are also tensors. A more sophisticated example is the Cauchy stress tensor T, which takes a direction v as input and produces the stress T on the surface normal to this vector for output, thus expressing a relationship between these two vectors, shown in the figure. Given a reference basis of vectors, a tensor can be represented as an organized multidimensional array of numerical values. The order of a tensor is the dimensionality of the array needed to represent it, or equivalently, the number of indices needed to label a component of that array. For example, a linear map is represented by a matrix in a basis, and therefore is a second-order tensor. A vector is represented as a one-dimensional array in a basis, and is a first-order tensor. Scalars are single numbers and are thus zeroth-order tensors. The collection of tensors on a vector space forms a tensor algebra. Because they express a relationship between vectors, tensors themselves must be independent of a particular choice of basis. The basis independence of a tensor then takes the form of a covariant and/or contravariant transformation law that relates the array computed in one basis to that computed in another one. The precise form of the transformation law determines the type of the tensor. The tensor type is a pair of natural numbers, where n is the number of contravariant indices and m is the number of covariant indices. The total order of a tensor is the sum of these two numbers. Tensors are important in physics because they provide a concise mathematical framework for formulating and solving physics problems in areas such as stress, elasticity, fluid mechanics, and general relativity. In applications, it is common to study situations in which a different tensor can occur at each point of an object. For example, the stress within an object may vary from one location to another. This leads to the concept of a tensor field. In some areas, tensor fields are so ubiquitous that they are simply called tensors. Tensors were conceived in 1900 by Tullio Levi Civita and Gregorio Ricci Curbastro, who continued the earlier work of Bernhard Riemann and Elvin Bruno Christoffel and others. As part of the absolute differential calculus, the concept enabled an alternative formulation of the intrinsic differential geometry of a manifold, in the form of the Riemann curvature tensor.